Who's training these models? Everybody. Really, the question you should ask is, who has interesting proprietary data? Everybody. I mean, as Abhi mentioned, there's a model size for everybody. There's a good entry point for everybody. And at the end of the day, it's everything from small startups for whom the model is their main product, companies like Replit that are very tech forward and AI first and recognize the power of this, to the kinds of companies that if I mentioned them, you'd say, wow, that's a really big, boring company. They're doing AI. It's because, yeah, I mean, they have amazing data. This is how you activate it. In the old days, he used to say like data is your moat. And then in the past year or so, there's been like this new kind of wave where we'll actually train the model so hard, maybe that's the moat. And so what Mosaic's doing is like, we're making that easy again. So it's almost like making ML training boring again.
Hello, and welcome to the Cognitive Revolution, where we interview visionary researchers, entrepreneurs, and builders working on the frontier of artificial intelligence. Each week, we'll explore their revolutionary ideas, and together we'll build a picture of how AI technology will transform work, life, and society in the coming years. I'm Nathan Lebenz, joined by my co-host, Eric Torenberg.
Hello, and welcome back to the Cognitive Revolution. Today, we're talking to Jonathan Frankle and Abhi Venigalla, Chief Scientist and Research Scientist at MosaicML. In today's world of AI hype, it seems like almost any project has at least some chance of going viral on Twitter. A few of those will prove deserving and enduring, but most will quickly fade away. To make headline news repeatedly, however, as Mosaic has done over the last year, is something that only truly top-notch organizations can do. Mosaic specializes in creating custom, proprietary language models for corporate clients. They were the first to offer GPT-3 quality models for $500,000 in September of 2022, and they were the first to train Stable Diffusion from scratch for under $160,000 in January of this year. They then turned around and did it again, announcing Stable Diffusion for under $50,000 in April. One funny note from the conversation, at one point you'll hear Jonathan give me a bit of a hard time for quoting the $160,000 number instead of the latest $50,000 number. I went back and checked, and it turns out that they announced that additional price drop in the few days between when I prepped for and when we recorded this episode. Just goes to show how fast things are moving. Most recently, Mosaic has released their own open source models, as well as an inference service that allows you to use their servers to power your applications. According to lmsys.org, a leaderboard that collects human evaluations on blind head-to-head language model comparisons, their MPT-7B chat model is currently the number 9 rated chat model in the world. Now that's already an impressive accomplishment, but what's even more impressive, when you remove the OpenAI, Anthropic, Google, and Llama-derived models from the list, it turns out that MPT-7B chat is actually the number 1 rated open source model that is available for easy fine-tuning and commercial use. Additionally, their release of the MPT-7B storywriter 65K Plus model, which allows actually even more than 65,000 tokens of context, legitimately shocked much of the AI world and set a new standard for long context models, which are already quickly becoming the norm. We'll talk about the alibi technique that they used to achieve this. We only had an hour for this call. As you'll hear Jonathan say, demand for MosaicML services is through the roof. They are reaching the point where they're making tough choices between serving additional customers and conducting additional research. Obviously, that doesn't leave a ton of time for podcasting, but I still think this episode is a great window into who is training their own language models, why they're going that route, what they're using them for, and the techniques that are powering this trend. Before jumping into the episode, a quick thank you to everyone who has shared the Cognitive Revolution with friends or posted a review online. We're now up to roughly 25,000 unique monthly listeners, and I am having a ton of fun sharing all of these conversations and everything I'm learning from them with all of you. Now, I hope you enjoy this conversation with Jonathan Frankle and Abhi Venigalla of MosaicML. Abhi Venigalla, Jonathan Frankle, welcome to the Cognitive Revolution.
Hey, it's great to be here.
Really excited to have you both. As you know, I've been a close watcher of and big fan of Mosaic for a little while now, and you guys have built an awesome platform and made a bunch of news recently with a number of product and model releases in the LLM space. So I've got a ton of questions and thought we could maybe kind of structure things by starting first with what I believe to be kind of the foundational layer of the business, which is the custom large language model training. Then I kind of want to get into the new inference side of the business as well. Definitely want to make sure we get to the 65K model that you guys recently released, because I think that's super interesting, and even want to dig in a little bit to how that was done and some of the new techniques that you have, I'm sure, not only applied but refined in practice. And then if we have time, we can even get into some bigger picture stuff. How's all that sound?
It sounds great.
Cool. So I guess when I think of Mosaic, what I have kind of understood you guys to be up until recently is the go-to place for presumably larger businesses, although you've done impressive work to bring the kind of entry point, sticker price down, but presumably mostly larger businesses that want to create their own custom large language models, I think usually from scratch. So the first thing I wanted to just kind of sanity check myself on is, do I have that right? And then we can dig in a little deeper to who those companies are.
Yeah, no, totally. I think you got it right. And I think we've sort of been expanding from that initial position recently in the past month or so. But yes, we started off basically trying to help people build their own custom models, whether it's large language models or diffusion models, originally, even burp models and ResNet 50s even back in the day. Really want to help people who have valuable proprietary data turn that into valuable models that they own, rather than necessarily leverage APIs and such. One way we've expanded from that is to try and make it even easier for people to build these custom models, so they can start from pre-trained checkpoints and kind of our recent MPT models that we released out there, or sort of these public checkpoints where it's already a pretty good language model and you can start on top of this and continue. And finally, the last component that we thought is that every person who trains models with us wants to deploy them for inference. So we figured, well, we should probably help them with that too. So that's also what we're trying to do. So we're really trying to help end-to-end people go from the data to these kind of private models, private endpoints that they own.
Let's unpack that a little bit more. Who in today's world is building, a custom large language model? And, how big are these models that they're building? We could talk about that in terms of parameters or token count on the training side. You've kind of answered already, but I was kind of curious to what degree you're seeing people use a combination of open source data sets versus just, how many of these customers actually have enough of their own data where they don't even need, any of the kind of standard data sets.
Yeah, for sure. I think we have a very wide spectrum of customers. We have people starting, training, sub-billion parameter models to, in the single-digit billions of parameters, and some even going well beyond that. You can see some of our customer stories like Replit recently. They trained a really powerful 3 billion parameter model that actually in some ways outperformed the first Codex version, right? So kind of out punching for its weight class. We really focus a lot on kind of efficiency in this way. We want people to be able to produce things that are smaller, cheaper for inference, cheaper for training, that still match the quality that they need. Now, in terms of data, this is the thing that we're really focusing on nowadays, which is that sometimes customers come with a lot of pre-trained data. They may have across all of their customer interactions or log logs and stuff, maybe tens of billions of tokens of data, but they want the model to also start with a general knowledge of the world, right? So there's a good amount of research we're doing now to figure out what are the data mixes that we want to do. We actually spent a lot of time creating the data for the FPT models that we released. But yeah, I would say I would expect customers to have a mix of both public and private data. I'll throw in one more thing, which is, to put a really fine point on answering your first question. Who's training these models? Everybody. Really, the question you should ask is, who has interesting proprietary data? Everybody. As Abhi mentioned, there's a model size for everybody. There's a good entry point for everybody. And at the end of the day, it's everything from small startups for whom the model is their main product, companies like Replit that are very tech forward and AI first and recognize the power of this, to the kinds of companies that if I mentioned them, you'd say, wow, that's a really big, boring company. They're doing AI. It's because, yeah, they have amazing data. This is how you activate it. So it really is everyone and everybody, trying to train these models. Yeah, actually, you remind me of something that I thought of a lot, which is that kind of, in the old days, people used to say data is your moat. And then in the past year or so, there's been this new kind of wave where we'll actually train the model so hard, maybe that's the moat. And I'd say what Mosaic's doing is we're making that easy again. So it's almost making ML training boring again. We're bringing it back to a position where actually your proprietary data is what makes your model so much better.
Can you expand a little bit on just kind of use cases? Obviously, you've got some names on your website, and then I'm sure, lots more customer names that maybe you can't disclose. But if you can kind of abstract away from, the sort of identifiable details of some of these customers, I think people are really curious about use cases. Like, are we building chat type agents to like help enterprises interact with their customers? Are we doing like task automation back office? What's that kind of breadth and mix look like?
The boring answer is it's a little bit of everything. But I think the main thing we see, especially with big enterprises, I can really sum it up as two tasks: extraction and summarization. Those seem to be kind of the core workhorse tasks that people want to get done. You've got a huge amount of information. You may get there because, a new court case came out and it's 100-something pages long and you want to understand what it's about right away. You may get there because you're using something like LangChain in a vector database and you've pulled up a bunch of really relevant documents and you have a lot of information that is relevant to some question. But at the end of the day, you really want to extract out the relevant piece of information or the relevant passage, or you want to get a summary and get useful information out of it. I think for a lot of our enterprise customers, it's as simple as that. For a lot of other customers, that they are looking at some specific application. We certainly have customers who care a lot about chat. I wouldn't say it's anywhere near the majority, but we certainly have some folks who either care about chat as their main application or care about chat, as a good user interface on top of one of these systems. And then, of course, you have customers like Replit that are doing something that doesn't really fall cleanly into any of these categories and is genuinely useful. So really, the models are as multi-purpose as, any other language model, but those are really, at the end of the day, those are kind of the boring, useful things that honestly these models are best at. And they're both things where the model doesn't have to be perfectly right. We're getting in the right direction. We're just trying to get useful information out of some data you already have is the most important part. And, you're not about to make an important medical decision on the basis of a summary that your model gives you, for example. There's still a human decision maker in the loop to make sure that, if the information is acted upon, it is in an appropriate way.
Yeah, I think that's great grounding. There's so much stuff going on in, the corporate world that is ultimately not necessarily super flashy, but there's just a ton of value to unlock because of how much of it there is and how much, more cheaply you could do it, or potentially also like how much more you can scale it versus what you could do in the past. I wonder if you could comment on that. I see a lot of, in the context of like task automation, sometimes it's like, I have this task, I do it today in a human powered way, and it's that, can be slower and more expensive than I'd like. So maybe I can take, time and cost out. But then the other thing that people often kind of quickly turn to once they start to wrap their head around this is like, maybe I can scale previously unscalable processes. So if it is this kind of extraction and summarization are the main things, how much of that extraction and summarization do you think in the pre-language model era was done by humans versus just like not done at all because nobody could get to it?
Yeah, I would say I'm much more excited about the latter, and that's also where I think customers are probably excited too. One thing I think about a lot is actually in the context of some of our work, our open source repos. Lots of times when people use it, they have questions, right? They like, oh, how do I actually use the script? Like, what should I be doing? What's the workflow? And right now, I think the best that humans can do really is to write like documentation, right? Or like write FAQs and stuff like that. But there's no scalable way to say like have someone next to you as a support person helping you through it, right? But with these models and stuff, we could actually build such a system, right? It seems like we can actually build higher and higher quality interactions with people that previously, like as we said, it just could not be done because of the cost and scalability of like having, one person for every customer. So I think that's where I would be most excited. Not necessarily like replacing, things that are done today, but enabling new things that can't be done today.
Yeah, I certainly see that in some of my task automation work. It quickly becomes like, geez, we could do 100x, of this. And some of these things are just almost every business has certain use cases. Like often it's like scaling outbound recruiting outreach. How are we going to get, to all the candidates we'd like to get to? Most companies just don't have the resources to do as much of that as they would like. And we're starting to see that kind of thing turn on. It's going to interestingly lead to some probably different dynamics in terms of how that communication actually works and like what it takes to break through and be effective. But we're in this interesting moment where it's like the early adopters are getting these kind of early benefits. And then, presumably there's going to be a new equilibrium on some of these things. Digging a little bit deeper still into why does somebody come to Mosaic? Because I can imagine, okay, I'm an enterprise. I've got these, for probably at the end of the day, fairly mundane, information processing objectives. I could go to like an OpenAI and, they also make it pretty easy to do fine tuning with just like, supervised input output pair paradigm of fine tuning. What is the main reason that folks say, I don't want to go with them, I instead want to work with Mosaic? Is it like control of data, cost? I mean, you're going to say all of the above again, but give me a little bit more than just the all of the above, because I kind of know what the suspects are, but I want to know like what the mix is and what you're seeing.
Hey, we'll continue our interview in a moment after a word from our sponsors. Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.
Yeah, totally. I think I'll focus on like kind of two customer profiles I see. Well, one is the type of customer, often startups, where they want to build a new product or like experience that truly cannot be done any other way than to produce like a custom model. They either have to train like a really custom domain like coding model, or they need a model that handles multiple languages, or basically like things where it's like, they've tried the APIs, it's not quite good enough, or it's not cost effective enough, and they really need to have their own custom model to do it. And so for them, it just makes sense, like, well, if I need to build an LLM in-house, I need to get the compute, I need to get the engineers, the ML researchers. It's a really expensive and honestly today pretty hard to find group of people to build something. Or kind of like the other option, right? You can just go to Mosaic and you build with them, and with a very small team, right, you can actually build these custom models for yourself. I would say that's like one type. Another type are people who actually are our users of like these API providers like OpenAI, Cohere, others, right? Where maybe they build the first version of their product on top of these APIs and it's going great. They've scaled users, they're getting lots of revenue, that's fantastic. And now it's sort of like, okay, now it's an optimization question, right? Like, can I potentially build smaller models or custom models myself and deploy them for cheaper, right? And that's like part of what we're targeting with Mosaic inference, right? We're basically trying to very clearly separate, the cost of training the model and the cost of deploying the model. And there's like only a small payment on top. It's actually very, very close to the actual inference GPU cost. Whereas opposed with OpenAI system, right, you're paying this per token thing, and the per token cost actually goes a lot when you fine tune. So I think like, for instance, some of the fine tune models think cost 6x as much when you go from like the base model to fine tune. With us, there's no such thing like that, right? It's sort of, we're very explicit about, here's like, the compute cost and cost power. It doesn't matter what weights you're putting on there, be the base models or models and so on. So that's where I think like we're trying to be a bit more transparent about all this and like passing those savings to customers and, give them a lot more flexibility than you get potentially with fine tuning. Do you want to say, John?
Yeah, I'll throw in, I think, from the big enterprise perspective, it's really three things. It is customization, control, and cost, and I love that they all start with C. That is convenient. On the customization side, a lot of folks, like enterprises have huge amounts of data that you can't put into a few input-output pairs. We've had plenty of customers come to us and say, I have several 100 billion tokens, or I have over 1 trillion tokens worth of data. There's no other way to get that data into your model beyond, doing a lot of pre-training, potentially from scratch. A lot of customers come to us and say, we want to customize the pre-training data for the model fundamentally. They look at, open source models and they say, well, I don't like that data set. I want a little more code. I want a little more of this. We basically have a menu at this point of what's available open source and how they want to put it together. With any of the big APIs, you have no idea, and that's part of the secret sauce. You have to hope that the thing you're worried about just isn't in that model. On the control side, we can do it within their cloud VPC such that the data never leaves. We can do it on-prem if they want to, and they own the model weights when they're done. Not just an API to the model where they can rent their own model forever, but they actually own the model. If they want to take it and serve it another way or open source it, we're fine with that. That's up to the customer, not to us. Abhi, I think, has comprehensively mentioned the cost side. It's just cheaper to train a domain-specific 3 billion parameter model than it is, even to try to fine tune in many cases a gigantic, 1.6 trillion parameter model from what I've heard, especially if you're going to do it on more than a few input-output pairs. So that difference really matters.
I've done a lot of fine tuning on the OpenAI platform in particular, and I've had some things where it's worked really well for me, and then I've had other things where it hasn't worked so well. where it's worked well has been, I have like a very defined task and I'm kind of dialing it in. I have a certain format requirement. I have certain like length, output requirements. And I, typically find it doesn't take that many examples to get there. But then I've also tried trying to train it to write in my voice. And that hasn't worked so well because, I only have so many tokens for one thing. And it sort of kind of learns who I am, but it's like still madly hallucinating, after at least the sort of data set that I'm able to muster. It sounds surprising to me on some level that there are this many established companies that are already this far in their large language model journeys. And I see, like everything's kind of happening, all at once. Right? We've got reports of like people banning ChatGPT at work. And then we've got reports of other people like, if you don't learn to use it by, July 1st, you're fired. I just saw a story like that the other day. But I am surprised that people are kind of seemingly moving on to like next generation, already. So I'm curious about that. And I'm also curious about like the nature of the models that they create. Like, are they creating these models that sort of have a very particular point of view on the universe? We saw, I don't think this is your customer, but like Wendy's, has like fresh AI. And I'm wondering like, do those AIs like know about a Big Mac, or do they have like just no conception of like what exists, outside of kind of their, corporate knowledge base kind of universe? There's a lot there, but I'd love to hear a little bit more about just kind of the color commentary of the sorts of journeys that people are on and the nature of the models that they're creating.
Yeah, so I think I'll like just go with the first question. Yeah, the number of companies that are building LLMs. I think we were also like, pleasantly surprised by the number of companies that we found like since I'd say last like winter or so, like when we really started doing this LLM effort. And in the beginning, I think it was mostly startups, but especially since the ChatGPT explosion, like a lot of like basically once the world like realized this is possible, we've seen many more enterprises like they basically want like a ChatGPT internally that they can use, like one that they can trust, one that they can actually control, like the data that's coming in, the recency, one that which their even internal like employees can use safely, right? As opposed to some of these reports of like uh, confidential data leaking into the ChatGPT system. So yeah, I think it's even if they're not like super far on the journey yet, they know right away that they're going to have to develop some kind of proprietary in-house system, not necessarily just. Yeah, so I can't speak too much like what exactly our customers are doing, but I will say it's not too diverse in that way yet. It's not like people are ripping out parts of Wikipedia and trying to control things like that. I think right now a lot of it's just sort of how do we incorporate our proprietary in addition to like general world knowledge. A lot of it is like making sure there's no harmfulness, no toxic behavior, that kind of stuff too. Some of it is even just like how do I incorporate new things like long context length or long form documents, which you couldn't do until very recently, like on the APIs. Of course, Anthropic now has like this 100K support as well, and we're really excited about that and the possibilities. But I think most things have been additive. I'm not sure I've seen too much of like the kind of like pruning away that you may be talking about. Maybe do you want to comment on that?
Yeah, I think what we tend to see is that all of our customers want a mix of some open source data and their internal data. If you were to just train it on your internal knowledge base, that model is going to have a pretty limited understanding of the world. And, the knowledge base may not even be in very clear prose in a lot of cases. So a lot of customers are mixing together open source data sets they think are a good fit with their own internal data. I do also want to kind of, popping up one level, I think you're framing this as, do you use GPT-4 or do you train your own model? And I think that's a false dichotomy. What we're seeing for a lot of our customers is that the answer is yes. There are certain use cases where GPT-4 is both great, and, allowable. There are a lot of use cases where either GPT-4 simply can't be used in those cases. There's sensitive data, or, there are a lot of cases where it's just not effective because we need to know about internal business processes that it simply hasn't been trained on because that's internal documentation. So what we see with a lot of our customers is, are they using GPT-4? Yeah. Are they using us? Yeah. And these are different tools for different use cases. But I don't think we're trying to say replace GPT-4 with MosaicML. we're trying to say there are a lot of different ways to solve these problems and a lot of different tools to do it.
Yeah, I think that's a good call out. And it's almost one of my mantras these days too, is like, it's never in AI right now, either or. It's always kind of both. And, that extends to like societal impact questions as well as kind of, which models and tools are people going to use. So I totally, that totally makes sense to me, that it's not all one way or the other. So it makes sense what you're saying there with kind of the mix of data. It makes sense then why you have these kind of checkpoints that are like a base to build on, like no need to rerun that sort of, Wikipedia pre-training time and time again, if you can kind of embody it and have the ability to branch off from there. When you do that fine tuning, are you continuing to mix in, like, what is the curriculum? It seems like we're kind of moving toward this like curriculum model where there's kind of this general, knowledge base, that is the checkpoint, and you're laying on the proprietary data. Are you still mixing in the open source data, or do you just kind of pre-train on their data and that works out okay? I don't really have a sense for if you can make that kind of shift from like data set A to B and it all works out okay, or if you kind of have to continue to bring, some of the base forward into the continued pre-training.
Yeah, I mean, I think the first thing I would mention here, I'm going to be really picky right now. I hate the word fine tuning, because when you show up and you say, I want to fine tune on 200 billion tokens, there's nothing fine about that. It's as hardcore as pre-training, if not more so. What we tend to see is kind of a mix of things. If they're going to build on one of our checkpoints, you do continue to mix in some open source data and create the right mix. It may not be the exact same open source data, but often, if a customer doesn't have the right representation of data anyway, simply training on a specific subset of the data they want the model to eventually know will lead to catastrophic forgetting. And so you do want to make sure that you've got, a good mixture of both, some more generic data and some more domain-specific data. I think this is in some sense a question as old as time when it comes to transfer learning and fine-tuning. There are papers from the BERT era, which was so long ago, 3 years ago, that were all about this question of how do you fine-tune properly? And, a paper called Don't Stop Pre-Training, which, should tell you the whole story there. So there are a lot of different, approaches to this, especially when you get into instruction fine-tuning and RLHF. You are doing a different task. And so you do want to change the nature of your data and probably don't want to mix, for example, instruction following and just normal continuation of natural language. But all this is really, the bottom line is all this is science yet to be done. We're experimenting, our customers are experimenting, we're doing things that seem intuitive, we're trying to test everything rigorously, and we're all learning every day. A lot of the best questions like this haven't even been answered in a really rigorous way yet.
Yeah, so basically no sharp line between continued pre-training and fine-tuning in many instances anyway. And yeah, starting to see too, like some of these, what had been understood or at least introduced as kind of late stage training techniques are also being backported into the pre-training, right? Like we're seeing just from the last week, I think, like pre-training with few shot, structure as kind of a, an earlier thing that could probably cite, several examples, but I won't waste your time. But yeah, it's interesting that both are kind of blending together and the techniques seem to be kind of going both directions at the same time as well.
Yeah, I think especially once we start getting to this situation where we just kind of few shot the models, few shot prompt the models. Even like the loss functions that we're using for fine-tuning and pre-training are exactly the same, right? We're effectively just giving sequences and saying, please match the sequence, please autocomplete it, right? And so previously, I think some of the distinctions came from at fine-tune time, I'm going to add a new head, I'm going to add a new classification head or an LM head or something. Now all of that's kind of out the window, and we're just continuing to train the original mates with new formats effectively.
Yeah, the great convergence. It is fascinating that, obviously the architectures have kind of unified, but also the loss functions, kind of converging to the same thing. Man, that is crazy. Are there any, so what I wanted to ask specifically about life sciences, because one of my personal goals is to have no major blind spots in my understanding of the AI landscape. And I, can't quite ever achieve that, I don't think, because it's moving too quickly. But I realize in looking at some of the stuff on your website that is kind of a gap in my knowledge right now. what is a language model? Maybe it's not even language models that you're training for them, but I had kind of understood it is, I think, language models in the context of the life sciences. What does that look like?
Yeah, so I think, we've done a bit of work, kind of on biomedical language models in the past. We worked with a team from Stanford, the CRFM team, to build, I think, BioMedLM, and that was just like late last year, where basically we wanted to have a model trained on just custom domain data, which was, I think, like PubMed papers, basically, so that you could actually ask the questions about like, medical like diagnosis and like things like that, and have it actually answer well. And you're seeing like a very similar trend happening at Google right now, I think, with their MedPalm models, the MedPalm, MedPalm 2, where they're actually able to like kind of put them head to head with physicians and actually see like, oh, could this be an augmenting tool, that like, helps you diagnose patients, helps you like respond to them, and stuff like that. So that's like one part where it is just genuinely like language models, but maybe not like biomedical language. There's another sort of direction which, we haven't gone too much into yet, but I understand, which is sort of like genomics, or like, kind of these more chemistry kind of applications where, like protein synthesis and like amino acid chain stuff are also just like sequences, right? And especially with some of the new like support we have for long context, can we help people in those domains too? Basically turning transformers for like protein sequences or something like that. I think that's like a really exciting question.
Cool. Any other customers or kind of, perhaps surprising language model use cases that you would highlight?
I mean, I don't know. I personally still find every use case of language models a little bit surprising in some sense.
Yeah, fair.
It's still new, and so everything is new and interesting. And honestly, our customers are really creative. So I think there's a lot of really cool multilingual work that we're seeing happening, where existing models are okay at doing multilingual stuff, but if you really want a model that's focused on a particular bilingual scenario, that seems to be incredibly popular right now. Languages that I would not have chosen if I were trying to build, say, a 5-language or 10-language model. So I found that to be really cool and really exciting so far. I hope our customers will talk about that at some point. I want to talk about it out of place for them, but we've seen some really awesome applications in that area, and it has me excited. It's not something I thought that much about. It puts a lot of pressure on the tokenizer, which is kind of interesting. Again, something that I find a very fraught subject. But it's cool to see all that activity and to see that we've reduced the barriers to entry such that, these applications are now within reach. You can build an LLM for an interesting language pair that certainly nobody would have picked right off the bat.
Yeah, that tokenizer has been interesting research this week, that has been billed as maybe the beginning of the end of the tokenizer. We'll see if that pans out. But I've seen also the one character from like a Hindi script, for example, might be in fact like 8 tokens because of the way it's all kind of broken down under the hood. And that is definitely something for listeners who want to go down that rabbit hole, check out how certain like Indian, language alphabets get tokenized. It's quite gnarly. I want to move on to the inference business, which you guys have just introduced in just a second, but just a little bit more calibration on kind of this data. People have these, hundreds of billions, a trillion tokens. It sounds like it's often kind of raw. How raw can it be before it becomes like a problem? And then like how tight do the resulting language models kind of stay to that knowledge base versus like, do they start hallucinating like plausible products, that these businesses might have, or, I imagine that same problem must exist, right?
Yeah, I mean, I think to a first approximation, your model is what you put into it. If you train a language model on a web data set that has a bunch of advertisements in it, your model will learn to start spitting out advertisements mid-sentence. That sort of behavior is definitely in these models. And so the data needs to be reasonably clean. You can't just shove everything in there. Not all tokens are created equal, but to first approximation, all tokens are created equal. You have to do a lot of work to get a high enough quality data set that you start to see this matter. This is why we place such a high premium on things like Wikipedia, on things like code that, tend to be relatively well curated, all things considered, from the beginning. And so just, punch above their weight token for token with other data sets. But if you're going to pull data from the web, let alone data from your internal use cases, doing good work on that data to clean it up can be really, really important. And, I imagine, models like Palm, models like GPT-4, that was the lion's share of the work in some sense. Once you have a good system down for training the model, data is a never-ending problem.
And to address the other portion, like how do you make sure that companies' products are represented faithfully and they don't like lose things? I think this is where like long context can really help, right? The more you can kind of shove into that initial prompts to the model, it's going to tend to that rather than whatever memories are stored away much more, attentively. And that way you can kind of ensure like, hey, here's a list of our actually, June 2023 products. Please refer only to these. I think that's a lot more, reliable than potentially in a retrain every so often, stuff like that too. So we're like investigating, our research team, lots of different ways to incorporate both long context, potentially in the future retrievable as well, to make it so for enterprises they can actually trust these models to have them.
How often are the customers able to kind of use something that comes out of the kind of bulk pre-training process versus layering on some sort of finishing instruction tuning or RLHF?
I think for most enterprise applications, you have to go through some kind of like this after training or polishing. I think, especially, you can even tell from the API providers, they usually have applied a lot of this kind of either instruction tuning or RLHF or something like that, so that you can actually speak to the model naturally rather than like kind of prompted very specifically to do what you want. I think we offer, especially on our Mosaic inference service, we offer like instruction tune models mostly. If you build your own, obviously you can start from the base and like, however you wish. But my gut feeling is that the instruction tune models are a little bit more usable.
Yeah, makes sense. I was kind of, from that, I'm kind of inferring also like, what the pattern of use is, where, again, in like some of the very highly tailored, fine tuning, which is, genuine, just like few, example fine tuning that I've done. It doesn't necessarily need to be instruction tuned because it's in such a controlled environment. There's a high degree of kind of developer architecture that surrounds what the inputs are even going to be. But it sounds like there's also a pretty good mix of companies just kind of creating these things and then making them available to their internal users to say like, now you can use this whenever you want. Is that a fair conclusion?
Yeah, no, I mean, I think in terms of evaluation stuff, the best way is to put the APIs in front of people, like internal ones, and just like see how they use it. I think as you're saying, right, especially if you're fine-tuning a lot of data of input-output format, maybe it's good enough to start from the base versus the instruction tune model. I don't think there's like any capabilities necessarily added to your instruction tuning. It's really just this kind of like massaging of the input outputs so that you can talk to it as you would to your friend or something like that. But yeah, so like, a common pathway might be, you start from like a base model, right? Either one of our pre-trained ones or one that you build yourself. You deploy Mosaic inference, and we have a nice little playground where you can actually talk to it and kind of like investigate how it's doing. Based on how that performs, you share that out with your employees. Then you build a fine-tuned model, and the next one, the next one. And it's really an iterative process to get the model to and where you actually want you or actually feel comfortable with. I can say we're putting a lot of work into evaluation for the next few months. We started off with kind of these academic benchmarks, and we have some blog posts as well on like how to do really fast like evaluation of these kind of in context learning tasks. But we have to graduate beyond that. These models are getting so good that effectively it's hard to even judge their quality just from these SQL tasks. So interactive evaluation, automated evaluation, all these stuff, I think so.
And if I understand correctly, that's kind of frontier right now. Like most clients are not, for example, like red teaming models yet, it sounds like, but you see that as the kind of thing that more will start to do in the not too distant future.
I see this as something that we're going to provide as a service to our customers. At the end of the day, if we are the one-stop shop for, making sure that you get a good model all the way from data to training to inference. A big part of that is making sure that the model you put out there is something you're proud of. So we invest a lot of resources when we work with customers to make sure they're evaluating their models carefully. Redteaming is a part of that. And so, I can't make any promises about a MosaicML evaluation product. I'm not going to announce that today, but you should keep your eyes out in the not too distant future for a little more detail.
I'm always very interested in the kind of red teaming risk mitigation side of that in particular, but obviously confirming that it does the happy path, effectively is also super important. let's talk about the inference business. You guys have layered on an inference platform to the business. And it's interesting because you both have like open source these, foundation models. People can go do whatever they want to do with them. Obviously, you don't see that as a threat to your ability to build a good inference business. So I'd kind of love to maybe just start with like the pitch for, the practical kind of way that people understand, even though this model's right here and I could go do it, what is the calculus that ultimately leads them to choose you? And then I'd love to dig into like the pricing a little bit more and kind of understand the cost structure to the degree that we can do that as well.
Yeah, absolutely. So I think kind of like starting at the basics, right? So you've got some of these open source models like on the Hugging Hub and stuff. Why not just try and like spin up a GPU yourself and serve it? And I think there's a lot of learning that happens once you actually start to try and do this and like serve it on an API to many customers. You realize that like kind of the libraries that you have today, it's easy to like serve one customer, but very hard to serve many, right? And you need batching, you need things like, lower precision weights, you need things like multiprocessing and auto scaling and stuff like that. And tuning all these things is quite difficult, especially as you get to these very, very large models. So the challenges I would say is that when it comes time that you actually want to serve, say, a 30 billion parameter language model, you find there's very few existing solutions out there that can actually achieve the type of performance or latency that you expect from like OpenAI or here and stuff like this. So that's like one big reason, right? We want to simplify all that infrastructure the same way we simplify it for training. And in terms of the cost side of it, really in particular questions I could answer.
Yeah, so I study this somewhat obsessively. So just looking at the pricing page, I noticed that it is 5/100ths of a cent per 1,000 tokens for the new MPT-7B instruct model, which I gather is kind of the new like mainline workhorse base model. And, to put that pricing a different way, at 20,000 tokens or 40 pages, you've now spent 1 cent. So you've got quite a bit of room to run there before you're spending much money. Where does that money go? Like, I don't know if this is something that you can even characterize this way. On some level, it could be, but it may be so many layers of abstraction. But like, do we have a sense for if I spend 1 cent on 20,000 tokens, how much of that 1 cent went to electricity? How much of it went to buying GPU cards? How much of it went to, I don't know if you guys use like AWS or multiple clouds or even run your own data center. So that'd be interesting. But like, how much of it goes to data center, management?
Without going into too many details of the exact numbers, I can help build up kind of the stack of everything that goes into that final cost there. So, so Mosaic, we deploy anywhere on any compute provider, right? So you could bring your own GPUs that you have if you have your own AWS account or Oracle account. You could rent compute directly from us, and we have some preferred partners, mainly Oracle right now, where we like rent a lot of these GPUs. And so as you build up towards like that cost per serving, right? What you're really trying to figure out is to satisfy a given workload. Let's say you need to satisfy like 10 requests per second peak or something, and you need to figure out, and you have a particular model size, let's say like the MPT-7 model. You want to figure out how many GPUs can satisfy that demand. And then you're basically renting those and running them full time, 24/7. So that's the thing about inference, right? Is that you have these servers that are basically running all the time, nonstop, serving requests. And so it's funny, sometimes training, at least, the job finishes at some point, but inference, it's running forever. So building up towards that, like, 1 cent cost you're talking about, right? You're paying a certain charge for renting the GPUs, and that both amortizes the cost of the GPU, usually over about 3 years or something, plus whatever electricity is being used for the data center. But for most people, that whole cost gets packaged up into like the rental price per hour, right? So maybe like, just putting a number out there, for an A100, it costs $2 per hour to rent, right? Maybe to your data center provider, the cloud provider, it costs them only like $1 to actually run the whole thing because they've got such economies of scale. But that's like the first part, right? So the price per hour. Then on top of that, the Mosaic platform service, we have a few ourselves that we put on top of that. But finally, when you're an enterprise customer, you basically just pay a per hour price. So we help you figure out for your inference workload how many GPUs you need. We help kind of point you towards the right GPU types that you want as well. Not necessarily A100s, which are really powerful, but a little bit of overkill for certain workloads. Maybe you want A10s instead. And then we help break that down effectively into the price graph. And so then finally, when it comes to your single request, right, what we're saying basically is that that one request, if it was happening constantly over the course of a month, it breaks down to only a little bit, 1 cent, versus like the monthly cost can be a few $1,000s.
So as it stands today, can I come and buy like on sort of an API basis, like one call against that new instruct model? So you have both a kind of pay per use or pay per token model, but it sounds like more of the business is ultimately, because people have their own custom models, I guess, they can't use shared infrastructure anymore, right? When they've got custom models, because you don't want to be like, you have too much load, cold start problems. So you're more often selling compute on a dedicated capacity basis. And the value add is helping people understand what dedicated capacity they need so that they can, spend efficiently.
Yeah, exactly. So we have two pathways with our inference servers. The first is the starter series, where there's a list of supported models that are basically models we built or open source models that you can just pay per use, right? So you can imagine that as kind of like a shared service that get providers out there. So I think that's maybe like the place where you got like the 1 cent per 40 pages, right? That's kind of a starter MPT segment model. Then once you train your own custom models and you want to deploy them, that's where you're going to transition to the enterprise service, where you're going to not be paying per request, but you're going to be paying this, like as you said, dedicated capacity that we help you figure out. And for there, it's like really, basically a cost per hour, and then that can satisfy a certain workload.
And do people, they buy that through you in a way where they don't even, like, do they know like, oh, I'm deploying this on AWS and it's kind of a transparent model, or are you like reselling the underlying cloud compute?
It is totally transparent, right? Like I think one of the core features of Mosaic is that we will run the workloads wherever it is required, based on your security constraints, based off your existing like contracts that you may have. And it's like optionally you can rent it through us, but it's just an option, right? So we treat ourselves just like all the other compute providers there.
Gotcha. Okay, cool. So if you had to estimate, going back to that original question, if I rent GPUs by the hour, let's say on AWS or on Oracle, what would you estimate their stack kind of looks like in terms of how much of their per hour cost goes to electricity? How much of their per hour cost goes to buying the physical hardware?
I think the simple answer is, that's their internal numbers and we don't know. And I don't think it's a good time for us to speculate on that. I would guess that the electricity is probably a relatively small amount compared to the hardware, but that's just a complete guess. And happy to refer you to our friends at Oracle if you want to ask them.
Yeah. All right. Well, I might take you up on that. This is something I definitely am trying to triangulate on, because ultimately, some of this stuff goes on the edge eventually, right? And then it's like you have no marginal cost of device, arguably, and it's just electricity. So I'm trying to kind of scout out a little bit to some, not that that's going to be the end all be all, but there's some part of the future that kind of ends seemingly at like marginal cost of electricity. So trying to kind of sketch out to like what that is. And it isn't super easy to figure it out. Anything else we should cover on inference? And then my next thing is to switch gears and go to the new 65K context window model.
The only thing about inference I say is if you're interested, please reach out, because I think we have very competitive pricing and a lot better, more transparent model than some of the other AI providers out there. So if you want to build custom models for them, just let us know.
And I will throw in on that, if you want it, you better reach out ASAP, because we're definitely getting, as our research team is learning, we are getting booked up very, very quickly. Certainly, we're making hard choices between research and customers right now because there's so much demand.
Yeah, I'm not surprised by that at all. Following your trajectory, from $500,000 GPT-3 quality, however many months ago, to the more recent, stable diffusion for I think it was like 150K or so, and now all this new stuff as well. Like, I would expect the phone is ringing off the hook.
Less than 50K.
Gotta get that number
Oh,
right.
less than 50K. Yeah. Okay. Thank you.
I think we crossed the price tag a few times, so it's changed a bit.
Yeah, you guys are hard to keep up with. It's a lot of releases. So, okay, let's talk about this. One of the aspects of the recent set of releases, the storywriter model, 65,000 token window, extends even beyond that. So I understand, I've read the paper a little bit, but I'd love to get a little bit better intuition for, it seems like this alibi approach is kind of the heart of the upgrade there. And what we're doing essentially is replacing the original old school positional embedding scheme with a new, seemingly more intuitively justifiable, principled positional embedding approach. But it still seems like the model like gets big still, right? Like to have that long token window, you still like attention still like scales with the square of the context window. Do I have that right? Nothing has changed about that, has it?
Yeah, no, 100%. It's still the same amount of work as before. We were just getting rid of the positional embedding and replacing it with a bias and the kind of attention. But yeah, so I think some of the nuances here is that quadratic portion of the attention is actually not as big as many people might think. For a lot of very large transformers, like if you're training them with a context of like say 2K, the actual amount of work being done with that kind of attention dot product, so it can be less than 10% of the overall work of the network. So yes, as we're stretching out the context of network from 2K to 4K to 8K, yes, we're stretching the 10% a lot bigger, that piece of the pie. It's not like ridiculously large. As a kind of point in the sand, when we trained our storywriter model with 65K context window, right? So we had the base model, and then we fine-tuned the song context. The kind of work done per token went up by about 4x. So you can think about like the cost to train on, say, like, a couple billion tokens was 4x larger for that context window than it would have been if you had trained just with a 2K context window. So yes, it is bigger, but it's not like ridiculously bigger.
So from 2 to 65, and it's actually even bigger than that, right? Because you allow it to go.
Yeah, so at inference time, you can actually you can technically go up to any infinite context length, but practically speaking, maybe like 2x more than it's been trained with, but yes.
So how can you have an infinite context? Is something just getting truncated eventually there, or you're like rounding at some like distance, you're rounding down to zero? Because otherwise, traditionally that would mean an infinite by infinite matrix, right?
Yeah, no, absolutely. The infinite is definitely has a lot of asterisks there. Like, your hard will run out of memory at some point, so it's not really infinite. And eventually you'll get tired of waiting as well, so that's not quite infinite either. But what is happening with Alibi is that there are these kind of slope biases that are being added. You can imagine like there's a slope from -1 to 1, from like the 0th position all the way to the end one. And when we go out to like a very, very long context from now, all we're doing is stretching that slope out because it's a continuous slope to whatever kind of target inference context window we want. So we trained with 2K and we went for like, -1 to 1 across 2,000 tokens. And inference time, if we want to do 4K, we would just stretch it out farther. So the bias being added can be basically morphed in that way.
So in the 65K model that you have released, is there still some sort of hard cap of like, this is the max number of tokens that this thing can handle? No.
Not really. So in the model, you can see on the Hugging face as well. The config, we have the max equals length of 65K, but you can totally adjust that, right? So you download the model, you change that one line in the config, and then when the model is instantiated, it will just create its alibi bias to whatever sequence that you wish. And you will be able to use inference up to say like 130K or something like that.
Yeah, I think the only two limitations that you'll encounter with Alibi, and this is why we love Alibi, is number one, you'll just run out of memory. That is your first limitation. So, you need a bigger, beefier GPU with more RAM to do this, or you need, fancier parallelism or fancy caching or things like that. The only other limitation is, that past a certain point, empirically, if you've trained in a certain context window, Alibi doesn't seem to extrapolate that well beyond about 2x, whatever the context window you trained on. So you'll run into kind of algorithmic issues there where the model, the quality of the outputs will start to degrade if you get much longer than that. But otherwise, really, Alibi can just keep going to whatever amount of memory you have. Find more memory, and that can give you a longer sequence.
So I'm still a little bit lost, and this is one thing I do where I just like fixate on things and keep asking questions until I try to understand it, or until I eventually hopefully understand it. I've got finite parameters, but in principle, if I had infinite memory, I could go to infinite tokens in the context window. Can you unpack that transformation of these like finite learned parameters into that infinite attention, approaching infinite attention matrix?
Totally, yeah. So maybe the best way is we could start with something that's close to a transformer, something that just has no position knowledge at all, right? So we have all the learned weights, which are like the word embeddings and the weights of all the matrix multiplies and so on, but nothing for the attention matrix, right? And so as you feed in tokens and you kind of save their keys and values, you can always keep attending to more and more and more. It's just that there'll be no position like information. So you're looking at a bag of words. You're looking at like a whole jumble of words, and your next token's attending to them, but has no idea which one came first. So that model you could stretch out to any context in which, right? There's no learned parameters going on with the attention now. The one thing that Alibi has is that it's this bias that is set up at initialization that can be stretched, and it's not learned. It's like a fixed set of slopes that go from like negative k to like k. And so that's the kind of matrix that you can basically adjust dynamically at inference time. To say, I want to stretch this out over 1,000 positions, or over 2,000 positions, or 100,000 positions. So that's what I say. So the alibi kind of mechanism is not like a learned mechanism, and that's what makes it possible to use whatever sequence you want.
Yeah, I think, to get to the heart of your question, the attention weights are shared. So for each position, for each, encoded token, you're using the same attention weights. You've got parameter reuse. And so technically, your sequence length doesn't matter. You can just keep reusing those same attention weights for any token that you have. In the same way that a convolutional network, in many cases can be completely agnostic to resolution because you're just doing the same convolution across multiple different positions in the image. So that's why fundamentally there's no issue doing an infinite sequence length other than running out of memory. You need somewhere to store the activations, but a finite parameter model, you're just reusing that same fixed number of weights over and over and over again at every sequence position.
Anything else we want to cover on the 65K? Anything on the flash attention or other, enhancements there that you think people ought to know about?
One with the model 65K, we showed some demonstrations that, the whole Great Gatsby and writing out an epilogue afterwards. But I'd say like one focus coming up soon is going to be on performance. Basically making sure that it doesn't take like minutes to write. I think one really impressive part of recent release is that the model actually writes quite quickly. And you'll probably see some content from us breaking down how to actually, use long context windows and where it gets faster and slower. So it turns out reading is a lot faster than writing these transformers. You can fit in 65K of context into the input, and that will go relatively fast. But then to generate every token afterwards will take some time. So you'll see a lot of improvements for those in the coming weeks and months of this, as well as potentially some new architecture features that make it even better.
I think I'll throw in perhaps, as we get in a last word, keep your eyes out on things that are coming from us. We've released a lot over the past couple of weeks, and that cadence is not going to be slowing down at all. We have a lot more work that's going to be churning out over the next, days, weeks, months. So I hope we'll be having these conversations a lot over the next while. MBT 7B and, Stable Diffusion for less than 50K. Those are kind of the boring baselines that we're going to be crushing over the next little while.
Well, that's a great teaser. I look forward, hopefully, to a part 2 in the not too distant future. And it sounds like you'll have some exciting new stuff to help us break down and understand. But for now, Abhi Venigalla and Jonathan Frankle, thank you for being part of the Cognitive Revolution.
Thank you so much for having us.
Thanks so much.
Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.